As we move into addition and subtraction, I wanted to make a quick video for you showing another way of modeling that you may not have seen before. Positive and negative integers really aren't part of the content of this course, but I wanted to show you this model as a way of expanding your understanding of how we can model things in mathematics. So, let's start off looking at some chips. We have a red chip. A red chip is a -1. A black chip is a +1. The concept that we need to understand for this demonstration is that if you have a red chip and a black chip together, that makes 0. +1 plus -1 is 0. With that concept, we can start looking at some problems. Let's take a look. Let's start off with a pretty standard one. Let's do 1, 2, 3, 4, 5. That's +5 plus +3. Simple counting. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let's take a look at another one. We have +5, but this time we're going to add to that -3. 1, 2, 3. As we said, one black chip and one red chip makes 0. So if we take a black chip and a red chip, put those together, that's 0. Those two, that's another 0. Those two, that's another 0. 2 plus 0 is 2. So +5 plus a -3 gives us a +2. Now let's take a look at another one. We have a +3, a +3 plus a -5. Again, one negative, one positive, that makes 0. A negative and a positive makes 0. A negative and a positive makes 0. And we have left 2 negatives. That tells us that +3 plus a -5 is a -2. One more addition problem quickly. If we have 5 negatives and a -3, and we want to add a -5 to a -3, we have a -8. Now, that isn't too hard, although in algebra sometimes we stumble over the combining of negatives and positives, but then we really do tend to stumble when it comes to subtracting with negatives. So let's take a look again at some problems. If we have 5, that's a +5, and we take away 3, we end up with 2. Straightforward subtraction, something we've all done. But let's go back and look at that 5. Now, this time we want to take away a -3. But we don't have a -3 to take away. But think back to that combination of one negative and one positive. That's 0. If I put these into my set, I've added 0. Didn't change the 5 that were already there. I just added in a 0 pair. Now I have one negative, but I need 3 negatives to take away. So I'm going to add in another 0 pair. Again, not changing the original 5 that we had, only adding 0. Now I have another negative pair. Now I have 3 negatives that I can take away. So I will take away the 1, 2, 3 negatives, and I end up with a +8. 5 minus a -3, that was my 3 negatives that I took away here, because remember, subtraction is taking away. I take away my 3 negatives and I end up with a +8. Now, what happens if I start with 5 red chips, or a -5. Now I'm going to start with a -5, and I'm going to take away a -3. Well, if I take away a -3, I end up with a -2. Now, let's go back to that -5 again. Do another one. This time, I'm going to take away a +3. That would be a -5 minus 3. Well, I don't have 3 to take away, so again, I need to add in a 0. Those two chips make 0. I'm adding 0 to my -5 and still having -5. I can add in another 0 pair and still have -5. Add in a third 0 pair and still have -5. But then I have my 3 positives to take away. So I take away those 3. That's +3. I took it away. And I end up with a -8. A -5 minus 3 gives me -8. Okay? So just a little demonstration to take your mind beyond the basic addition and subtraction that we usually think of into, well, now it's being taught in 7th and 8th grade, but in algebra and working with positive and negative integers and modeling those using manipulatives in a way that makes positive and negative integers much more real for students.